So we are going in this lesson. We are going to look at the .NET framework, what it is, and what are the components that compose the .NET framework, and what are the responsibilities of each component that is found within the .NET framework. .NET framework is a platform for developing software application for the family of Windows operating system and other non-Microsoft operating systems such as Mac OS, Unix, Linux, and many other operating systems that are .NET aware. So the framework is divided into three components. There are basically three components of the .NET framework: the CTS, the CLS, and the CLR. Each component plays its own unique role in the .NET framework. So we are going to look at each component one by one, investigating or examining each component's responsibility in the framework. The first one that we are going to look at is the CTS, which is basically an abbreviation that stands for Common Type Specification. The Common Type Specification component of the .NET framework has the responsibility of ensuring that it lays down a set of types that are supported by the CLR, which is one of the components of the .NET framework, which is responsible for code execution. So the CTS has a list or a set of types that are supported by the CLR. So basically, types are a representation of data in memory. The main reason we write software application is because we want to process data. So there are basically different types of data that our applications processes, such as numbers, and numbers are different. They are integers, they are floating point numbers, numbers with fractions, there are string literals, which means data points that contain letters. So basically there are different types of data that are processed by our application. So there must be a way to represent these different types of data in a computer memory. So the CTS, a type, it's basically that description or definition of how a data should be presented in memory. So .NET has a list of numerous data types. That means numerous description of how data should be presented in memory. Does that make sense? So the CTS has these set of types for representing data in memory. So basically, the different types of data can be categorized into subcategories. For example, at its core, there are only two types of types in a computer. There are reference type and there are value type types. Does that make sense? So the difference between these two is in how they store data. Your computer RAM, it's basically composed of two types of memory. One, stack memory. The second, it's the heap memory. So reference types allocate their memory on the heap memory, while the value types allocate memory on the stack memory. Does that make sense? So it's not difficult to tell which types are reference type and which types are value types. It's simple. Cool. So any type that is a class is a reference type. Any type that is a delegate is a reference type. Any type that is an enumeration, this one is a value type. Value type, enumeration, struct are value types, and what else? Interfaces are reference type. Types can also be categorized with these categories. Yeah? These are different types that we have in .NET framework. We've got interface types, class types, delegate types, enumeration type, and struct type. So these two types of types are value types. That means they allocate their memory on the stack memory, while these ones are reference type. They allocate memory on the heap memory. So the difference between these two types of memory, it's in basically the speed at which you can access the data points that you store into them. The stack memory, it's a bit quicker to access data out of the stack memory, while it's a bit slower to access data out of the heap memory. The other difference is that the stack memory is automatically managed by the microprocessor of the computer that will be running your application. The heap memory, you have the responsibility as the writer of the software that you'll be writing to do what? To manage the heap memory. Thanks God, when you write your application targeting the dotNET framework, you do not have to be concerned about managing this memory, as the dotNET does provide a subcomponent within one of its component that is responsible of ensuring that it manages the heap memory. Otherwise, in other languages such as C#, where when you are writing an unmanaged code, that is a code that is not going to be hosted by the CLR, that means a code that is not going to be hosted by the dotNET, then you have the responsibility to manage that part of the memory yourself. And the failure to do that will basically result in performance bottlenecks for your application, as you are going to experience what in programming terms is called memory leaks. You're going to allocate a lot of memory there, work with that data and pass it, but the memory, the data that you have, maybe let's say you have finished processing, will be still allocated on the heap memory. Does that make sense? But with stack memory, automatically the processor of the computer that will be executing application will manage that memory for you. So every time you are done processing the piece of data point, then it's going to be deallocated. That is going to be removed from the memory, opening space for other data points to be allocated and be stored on that memory, while they still need to be processed. Does that make sense? So when you are working with a class type, you must know that memory is going to be allocated on the heap. When you are working with delegates, then memory is going to be on the heap, and interface memory is going to be on the heap. But when you are working with a data point that is of type struct, then the memory is going to be on the stack memory. We're going to look at the type hierarchy in dotNET framework so that we can see which types are value type and which types are reference type. Does that make sense? So the dotNET framework represents its types in a form of a hierarchy, like a family tree. At the top we've got our parent, our grandfather, your grandfather and your grandmother, and then your grandfather and grandmother from your father's side, they give they give birth to your father, and then from your father give birth to me, and then I'm gonna give birth. So basically dotNET follows the same nomenclature. At the top there's a parent type. At the top of the hierarchy there's a parent type, a type that basically provide the functionality that needs to be provided by each and every type that is available in the dotNET framework. And that type is called the object type. The object type. So this is one of the dotNET framework's types. So this type provides the functionality that each and every type that is each and every type that is on the framework has to have. What am I saying? I said this type, it's the parent of all the types in dotNET framework, including the types that you are going to create yourself. You can create custom types. They will implicitly inherit from this type. You don't need to explicitly inherit from this type, but when you create a type, when you create a custom class, you custom delegate or interface, automatically or implicitly it's going to inherit from this type. Does that make sense? So from this type, we have got a type that is called value type. Value type. There's a type called value type, which basically, obviously, as its name says, when you create when you want to work with a data point which is of this type, the memory to store the data point that you will be working with will be allocated on the stack memory, where it is faster to get the data out of. Does that make sense? Fine. So from the value type, then there are several other types that inherit from it. And it includes types such as integers, includes types such as floating point numbers. It includes such as double, include types such as date time to represent date and time, years and what. And types such as characters to represent a single character. There are basically several of them. Types such as, let's see, what other type can be? Long, and we've got short here, short integers. So all these types, they inherit from the value type. Yeah? So when you want to work with numbers, integers for example, obviously going to make use of this type to tell the runtime that you actually require to be allocated and enough space to store integer numbers. So basically these types, when you declare your variables, declaring a variable, it's basically indicating to the compiler that you want to be allocated a certain amount of memory where you are going to store a data point of integers, that is numbers. So integers, it's basically any number that is between 0 to 2 to the power of 31. So any number that is within that range is an integer. So when you are working with numbers, when you know that, okay, I'm going to work with numbers that will be on that range, then you declare your variable as an integer, which means you will be indicating to the compiler that I need you to allocate enough space to store any number that is within that range. So this is how you declare a variable in C#, the type of the data point that you will want to store into that variable, and the name of that variable, then the value by using the assignment operator. Cool. So now the compiler, when it comes to execute this line of code, what it's going to do, it's going to look, okay, this person wants to store an integer into memory. Yeah? So it's going to go to your computer's memory, the stack part of your memory, because this is a value type. These are basically structures. Int is a structure. Within .NET, it's defined as a struct. Floating, all these are value types. So it's going to allocate a memory on the stack memory that is enough to store any number that is within that range. Does that make sense? And when you assign a value, it's going to take that value and store it into that memory. So after this line, then you can be able to access whatever you have stored into that memory through the name that you have given to your variable. So this is declaring and assigning your variable. Does that make sense? Sure. So these types are defined within the CTS component of the .NET framework. Within the CTS, we said CTS is an abbreviation that stands for Common Type Specification. Specification. Does that make sense? Cool. So, and normally these types, we refer to them as simple types. So when they talk about simple types, give 3 types of simple types, you give 3 of these. They are also more often referred to as intrinsic data types. These are the intrinsic data types. So when they say intrinsic data types, they refer to these types. Other intrinsic data types will include, these ones are reference type. There's a type called array that allows us to work with a set of numbers, like a set of numbers. When you have a collection of numbers that you will want to work with, you can't declare a variable for each number that is on the collection. You are able but to declare a single name where you're going to take that collection where you are going to store all those numbers. The other one that is a reference, it's a string that allows us to work with literal data, your names, the names of people, the names of school, the names of what. So any data that includes literals, we use the string. So basically, when you declare a variable of any of these types, then the compiler has information about how much space you need, where it should be, where the memory should be allocated on the stack or on the heap. So depending on the type of data that you will be that you will want to work with. Does that make sense? So the others are the maximum or minimum values for that data type, so that if you try to assign anything that is not within the minimum and the maximum value, then the compiler can let you know. So these types actually contain information such as that. Does that make sense? Sure. So basically, all these types are described under the CTS rule. There are a whole lot of types that are in this CTS, but these ones are the most common ones and they are the simplest ones.